Here's another example. Common log of x plus common log of x plus 9 equals 1. So again, if you don't see the base, remember this is really base 10. So here's what you cannot do. You cannot exponentiate each term on both sides. Okay, so remember if you have, let's say, x plus 9 is equal to 16. So this is a separate problem here. Let's say if you wanted to take the square root for some reason, you can take the square root of the entire left-hand side and entire right-hand side, right? What you cannot do is take the square root of each component. So the same thing applies here. When you are exponentiating or taking the log, you have to do it for the entire left-hand side or the entire right-hand side. You cannot distribute, quote unquote, to each term. So you could technically exponentiate the entire left-hand side like so and the entire right-hand side. However, this will not help you because when you're canceling it out, because of this plus sign here, you can't cancel it out like so. Okay, so what does that mean? What can we do? So think back to 4.4 where we had all those properties. We're going to want to condense into a single logarithm and then exponentiate. So remember when we're adding, right, when we're adding here, the arguments are going to be multiplied. So what I really have is common log or log base 10 of x times x plus 9 equals 1. So you could rewrite that as log base 10 of x squared plus 9x if you'd like. You will eventually have to do that anyway. And now I have the same setup as before. I have a single logarithm equal to something else, like a number or another log. So now I can exponentiate both sides by base 10. The 10 and the log base 10 cancel out since they're the inverses of each other. And I have x squared plus 9x on the left-hand side. 10 to the 1 is just 10 on the right-hand side. And notice I have a quadratic equation. These always tend to come up regularly, it seems, and it is the case here as well. So you move everything over to one side. You're going to factor and solve. So it's going to be 10 and 1. You need two numbers that add to be 9x. So that's going to be positive and that's going to be negative because positive 10x and negative x, right, adds up to be 9x. 10 times negative 1 is negative 10. So that means x equals negative 10 using the zero product property, right? Or x equals 1. And remember, we need to check our answers. We're looking to see that every single argument in the original equation before we did any kind of condensing is positive. If it fails to make any of the arguments positive, then you have to toss it out. It's an extraneous solution. So negative 10, okay, that fails right away because your argument is negative, so that's going to be out. Let's take a look at 1. That's good here. 1 plus 9 is 10, so those are both positive, so we're good. X equals 1 is the only solution. So as a heads up, you can have two solutions. You can have one solution. You can also have no solutions. Okay, so go ahead and try this problem here. So the first step was to condense the left-hand side and write as a single logarithm. Then you can exponentiate both sides by base 12, giving you x squared plus x equals 12 to the 1, which is 12. And when you solve that quadratic equation, you end up with x equals negative 4 or 3. However, when I check the argument of the original equation, the negative 4 fails and positive 3 works, so x equals 3 is the only solution. Be careful that you don't toss out answers that are negative right away because it may or may not make the argument negative. You could have a negative number as your answer and have it still be a solution, and have a positive number as an extraneous solution. So do check your solutions. Go ahead and try this problem here. Solve for the value of x. So here it might be helpful if you put a parentheses around the argument. That tends to visually help students. And notice because we are subtracting, we can divide the argument. And it simplifies to the common log of 15x equals 1. Remember, this is base 10. When I exponentiate with base 10, I get 15x equals 10, and x equals 10/15ths, or when reduced, it's 2/3. So if we put 2/3 into the argument of the original equation, well, I don't have to plug it in here because there's no variable, it's just right here. I see that it gives me a positive overall value. Therefore, 2/3 is your final answer. Go ahead and try this problem here. So because I have two logs on the left-hand side, I need to condense it. So when I condense it, remember you have to move that coefficient as a power first. And then I can use a product property by multiplying the arguments on the inside because it's a addition. And since this is base 10, right, I can exponentiate both sides by base 10. And this gives me 8x cubed equals 1,000, because 10 to the third power is 1,000. So at this point, we're solving for x. You could either take the cube root right away or divide by 8 and then take the cube root of both sides. So cube root of 1,000 is 10 and cube root of 8 is 2, giving me 10 over 2. And 10 over 2 reduces down to 5. So remember, we need to check to see that our solution gives me a positive argument. So go back to the original. Notice this is the only argument that has a variable in it, and 5 is a positive argument. So therefore x equals 5 is your final answer. Here's a last U-try problem. So on the left-hand side, if I want to write this as a single logarithm, I first have to move the coefficient as a power. And then because I'm subtracting, I can divide on the inside. Note that you have a base 10 here, so you can exponentiate by base 10 on both sides, yielding x squared over 4 is equal to 10 to 0, right? 10 to the 0 is 1. So multiply by 4 on both sides, you get x squared equals 4. And then I'm going to take the square root of both sides. Remember, anytime you take an even root, like a square root or 4th root, 6th root, you have to account for the plus or minus. So you get x equals plus or minus 2. Now let's go ahead and check the solutions into the original equation before we did any kind of condensing property. So if I plug in 2, right, again, this is the only log with a variable inside the argument. I'm good because that's positive, so x equals 2 is a solution. If I plug in negative 2, the argument is negative, so that is an extraneous solution. Your final answer is x equals 2 only. So for this particular problem, because you have a 0 on the right-hand side, you also could have done it this way. You could have added log of 4, common log of 4 on both sides. And then you can move the coefficient up as a power here. And then you would have a single log on either side of the equation. So you can either use 1-to-1 property where you set x squared equal to 4, or you can exponentiate, since this is base 10, by base 10, canceling out the logs, getting x squared equals 4. And at that point, you would end up at this step here where you take the square root to get plus or minus 2, checking your answer to only get x equals positive 2 as your final solution. Again, this was a special case. It only works this way if you have a 0 on the other side.